Thank you everybody for joining. This is our second webinar on the Making AI Approachable series. The theme today is customize your AI. And your host today, my name is Mikko Peltola, and I have Dr. Petri Salonen here with me. I'm from ACX and Petri is from TELLUS International, and we have partnered to deliver this webinar and also the other webinars that we are presenting. Our offering is complementary, so ACX focuses on helping companies build better products through design and engineering. We have product making background, while TELLUS International is focusing on the strategy. So I will hand over to Petri. We'll make a brief introduction about the companies and then we'll jump right into the content. Petri, off to you.
Thank you, Mikko. Nice to see you all here. So TELLUS has been around for 17 years and we've been mainly focused on delivering strategy, business design, and visioning workshops for Microsoft partners, large ones, global ISVs, as well as smaller ones. And when you look at the types of workshops, I'm really, really excited about the partnership with ACX because, we have our output from the envisioning, road mapping, business design workshops are typically when an organization such as ACX starts working, whether it's a prototype design and the actual implementation. And I have never been able to deliver that through the TELLUS, so that's why we felt that this is much better to get a story. And as you can see from the logos, we've been delivering workshops for brand names for years. So we have a well-structured framework, business modeling framework that applies across different types of organizations. Back to you, Mikko.
Excellent, thanks, Petri. So ACX, these are the founders and the leadership of the team. And as you can see, we are mostly a North American company. We have presence in the Bay Area, in Dallas. Most of our tech team and design team is in Vancouver, and then we also have presence in Finland. And in terms of content, just briefly on the design side, we can cover research and insights, UX design, visual design. And then we can move into the development, cover the front-end development, secure back-end DevOps. And we focus on the kind of forward-looking technologies. We played around with the extended reality and artificial intelligence a lot. So let's jump to the topic of the day, customizing your AI solutions. And let's first think about the need. So when is it necessary to customize your AI? We mostly talk about large language models, so something like ChatGPT, but partially this is also applicable to images and videos and other branches of AI. So quite often AI doesn't know the answer you're looking for. It may be because the knowledge isn't public. So if you want to use AI model for your own product or for your own IT, you cannot expect the AI model to be aware of the things that are specific to your domain or your company. Also, there are instances where the data just isn't known by the model. For example, the model has been trained some time ago and it doesn't have the latest and greatest data. It's also good to remember that the AI models are not search engines, at least not all of them. So you cannot expect them to know everything by default. Then there are cases where AI shouldn't access the data. So you may have proprietary data, you may have client secrets, you may be operating in a regulated industry. So if you look at OpenAI, Azure, and many other players, they pledge that whatever you send to them is not used to train the model further. So they have no access to that data. But it's better to be safe and sorry. And it may be easier to explain to your partners or anybody who wants to know that you have taken care that no confidential data is leaving your domain. Also, you may be familiar, like when you use something like ChatGPT, you don't really control the output. So the tonality may change and the tonality may not be in line with what you want to express from your application or service. So it may be that your corporate language is very serious or it's very playful and youthful, So the standard box answer coming from the AI model may not fit that need. Also, these like ChatGPTs, they tend to be chatty. They like to talk, and the answers are long and winded, and you may want to provide a short and concise answer. So that requires some customization. And then thirdly, you may want to control the format. So you've seen sometimes it's like long form of text, it could be bullet lists. You may want the answer to be in the format of a table, so you can instruct the models to give the answer in a certain way, but it may not come out as you wish without those instructions. And then finally, there is a situation where you want to control the cost of AI. So being precise what the input is and what the output is and how the model works helps control the cost.
Mikko, I have a question here, and one of the key things, I might be asking questions here only way because Mikko and I've been working on this presentation and previous presentations, and there's a lot of questions that one would assume to know, but you have to go in more depth, and I think the cost side of AI is something that people typically don't have an understanding of because it's a multifaceted thing to be looking at, right?
Yes, yeah, it is. And that's a good point. So we have some cost examples here because it is one of the core elements, but there have been so many questions around the costing, we actually decided to dedicate our next webinar for the cost aspects. So we'll be scratching the surface here, and then the next webinar on the 15th of August will be more focusing on the cost.
Great.
Good. So if these are the needs, then what are we going to cover in this presentation? What are the ways of customizing the AI system? And here are some examples. So first one, there are many base models to select from, and selecting the right base model sets maybe the biggest impact for the system. Then there is something called fine-tuning, where you can customize the underlying model. It has some benefits and some disadvantages. Also, it's important how you ask the question, so how you design your prompt. There are also terms like engineering the prompt and metaprompts, and we'll be looking into those. You don't always need to go and fine-tune the model. You can also enhance the model, and there are techniques like grounding, copilots, and plugins that help you change the model behavior and access to external data without fine-tuning the underlying AI model. And then there is also like filtering, both filtering the prompts and responses. So this is not the comprehensive list. People are always coming up with new things, but here are some basic ways of customizing your AI. And when you go into the strategy discussions and the budgeting discussions in the coming fall, autumn time, be sure somebody will be popping up the AI question. And it's good to have an understanding, even if you're not a technical person, it's good to have an understanding of the basic terminology and like how those impact the outcome and the costing.
And I think one of the key things as well is that you and I have noticed this field is moving so quickly that once you think that you have got something in good check, you realize that it's already moved on to the next stage. And that's why A CX and TELLUS, that's what we do for a living. We do the research. We make sure that we are on top of the field in the topics that we decide to focus on, right?
That's correct, yes. And you shouldn't consider this presentation as a definitive answer. It's probably dated by tomorrow if something changes. But when you have like the basics, then you can get in touch with others or get in touch with us or others and find out what's the latest and greatest in the industry. Good. So let's move on then. We will look at like a stack. This is the Microsoft view of AI stack. They call it Copilot. A bit misleading because Copilot is also one of the elements here. But want to present this framework. So when we move from one customization like approach to another, we will show you this picture, and it hopefully gives you some comfort that there is like a means to our presentation. So why we selected these ways of customizing the AI. So let's start from the basics. So the foundation models. So selecting the right model, like I said, has a big impact on the performance and cost of your model. And there are different foundation models. So you can have hosted model. So somebody like Microsoft hosts the model like OpenAI model. They can be further fine-tuned, or you can bring your own models, like there are many models available free or for charge. Now, let's first introduce the concept of token. It's important when we start looking at this like difference between the models. So when you operate an LLM, like AI system, the cost is based on tokens. And normally the measurement is 1K token, so it means 1,000 tokens. And here on the right-hand side, you see like a sentence, Ramshree loves working at the Supermem's office. And each colored section is one token. So you can see that one token can be a full word, it can be a few letters, or it can be a single letter, depending how common these are, how it's built. Now this 1K tokens, so 1,000 tokens, represents about 750 words, which is a bit over 1 page of text. It can be over 2 pages, depending on the kind of text that you write and the language you are writing it with. So remember, when we talk about tokens, it's normally 1K token, and there's a price for that, and it's about 750 words or a little bit over 1 page.
So you can't really measure. I mean, it might be like you said, if it's a very commonly used word. So it's not one-to-one.
No, it really depends on what kind of language, what kind of words you are using.
Exactly.
And that is part of the kind of complexity of estimating the cost with AI. There are many variables. Engineers and finance people like definitive answers, but often you get an answer, it could be something like this. So now looking at the right pre-trained model, this is case OpenAI. On the left-hand side, you see 12 different models. These are commercially available AI models, and ChatGPT is based on a version of DaVinci, for example. So it is like a web interface to one of the models. There are many different models. Some of them are cheaper, some of them are more expensive. It doesn't mean that the more expensive one is always better. It depends on what is your use case, which model you should be choosing. And this is just OpenAI. Azure, Microsoft uses the same OpenAI models, but there are many others from Google and Meta and the other players. The reason I present this here is that the selection of the model has quite significant impact on the pricing when the volumes go up. So if we take the cheapest model here on the left-hand side, you see that you're operating ADA, and these are cost per 1K tokens, like we presented in a previous slide. Using ADA, the cost is like fractions of cent per 1K token, so 1 page of text. So it feels like it's nothing. So if we assign a relative cost of 1 for ADA, on the right-hand side, you see the one in a black box. If we go to the other end of the spectrum, and we look at the green cells, so DaVinci and GPT-4, you can see that the relative cost is 300. So it can be 300 times more expensive per 1K tokens to operate the high-end models than the low-end models. Naturally, if your volume is very small, these are still not significant costs. So you see there's 6 cents, 12 cents maximum per request or a prompt or response. So it feels like these are cents or fractions of a cent, but when the volumes go up, they can become more expensive. You also see a section here or column training. So some of these models can be trained, but there's a separate cost for training the models. So let's take an example what it could mean on the more expensive end of the spectrum. So if you take this GPT-4, which is the latest and greatest model from OpenAI, it has a version which is called 32K context. So instead of 1K, you can have 32K tokens there, which is up to maybe 40 pages of text, could be a bit more. And if you manage to craft like a prompt that takes all these 32K tokens, so you attach like a lot of text there, PDF, something like that, it's 32 times that 6 cents, so it becomes almost $2. And since the responses are priced at 12 cents per 1K, the response could cost up to almost $4. So all of a sudden, we move from like fractions of cent to almost $6 for one question and response. This is an extreme example. You typically don't manage to spend like 40 pages in a request, but it's possible. And one thing to remember is that the GPT-4 is still in limited release, so you cannot use it for like a great volumes, but soon you will. It might be something to consider that, or it's a good example to demonstrate that the latest and greatest, it's not always fit for all purposes. So you need to know which underlying model you choose.
So Mikko, in the next webinar, 15th of August, we are talking about pricing. So if you look at these input and output, so the assumption is that there's value added provided from 192 to 384. So the output is assumed to have more value than the input.
Yes, it should. Yes, exactly.
Yeah, and we're going to be looking at some value-based pricing frameworks in the next webinar.
Yes, correct. It's also good to remember that unlike ChatGPT, most large language models don't have a conversational like a memory in their history. So we are used to operating ChatGPT so that we ask something and then we can refine the answer. If you build your own solution, you need to drag that conversation history or summarize it every now and then. So the prompt gets longer and longer and consumes more and more. Now, again, if you have a limited number of users, it's not much of a concern. On the other end of the spectrum, if you make like a public-facing service where anybody can ask questions and you put very costly model behind that, it might be a concern. Somebody might even like misuse the system and just like load you with questions. And if it's $6 a pop, it gets expensive quite fast. Naturally, for example, Azure and AWS, they offer budgets, so you can set limits. So these problems can be addressed. You just need to know what is the possible problem and how to address it.
Mikko, I'm using a solution called the Brain, which is kind of a mind mapping multidimensional model. And last night, in fact, I watched the latest release, which has now large language model included. Anybody can go and check it out. Fantastic. My question in my mind was that who is paying for that? Because they are letting also people that don't subscribe to the service use it. But it is going to be embedded in every single software solution.
Good. Yeah. Well, it's good to remember that whenever there is something free, you are the product. So probably they want something out of you. It may be that it doesn't really harm you in any way. So they just want to learn what kind of questions you have in mind and how you operate the system. But it's only a few months ago that OpenAI was still using the prompts that we provide through ChatGPT to train their model. They have retired that practice, but it's good to be careful in this like fastly evolving space. So this is the base model, like selecting the base model and some of the implications it has. When we start looking then ways of customizing the AI, let's look at the kind of heavier lifting first. So this is kind of engineer's dream. Let's build our own system. That's a response from many engineers. So on the right-hand side, you see how like a very simplified LLM model works. So you have an input layer. You ask like where you're providing the inputs, and then you have the output layer, the outcome, and then there is hidden layer, or actually tens, almost 100 layers in some cases, that are then calculating the probabilities. So an easy AI example would be that if you want to predict the price of a car as an output, you can input the make and model and year and color, and then it calculates and gives you the response that this is the potential output. Now, we have these pre-trained models that are pretty good at doing things, but like we explored, they don't know all the data, they don't know your specific situation. So there are different ways of fine-tuning this. We talk about retraining, which is a complete makeover of the model. You're not using the existing data there. There is transfer learning, where you are reusing a model that's used somewhere else, and fine-tuning, which is like a flavor of transfer learning, where you're adding to the pre-trained model. So you're taking some of the data out, or you're replacing some of the data with your own data. And like a good example of this is, for example, if you have email classification service and you want to retrain, you want to like use transfer learn that for spam filtering. So it's in the same domain. It has the basic understanding, but the use case is a little bit different. When you enter into these kind of discussions, the engineer's dream kind of domain, some things that you should consider is that who has the data you need. If the pre-trained model doesn't fit your purposes, you need to somehow add data to it. Is that data you control? Is it something your partners and customers control? Is it public data? How do you collect that? And then, of course, there are some requirements for the data quality that you can use. Then who builds and maintains the model? Do you have the competencies in-house, or do you need a partner for that? And maintaining here really has like two flavors. One is that like if you operate in a domain where the data changes all the time, so it's like highly fluctuating, or there is some like discontinuity, like COVID discontinued many data models, many ways of behavior. And if you had a model, you probably had to redo that. Besides data, the underlying models also evolve quite fast. So at some point, you probably want to have an architecture or design where you can like update to a model that is better and fits the purpose better. The cost consideration is the second one. So when you start tuning your AI models, you will pay more. So you may have spotted in the slide where I showed the prices that the OpenAI cost multiplier is 6 times per token. So if you use the plain vanilla version versus your fine-tuned version, each request response costs 6 times more. Azure OpenAI, the Microsoft flavor, has a different way of addressing this cost. The token price is the same, but they charge for hosting that fine-tuned model, and it can be up to $2,000 a month. And as said, there are many other players in this field, and they may have different pricing models. Another thing is these pricing models tend to change quite a lot. So earlier in the year, Azure changed OpenAI changed some of their pricings, and the price reductions were 25% to 75% per token. So nothing is fixed in stone. If you want to calculate a business case and you use some prices, it might be that those have changed a year down the line quite dramatically. Also, the cost of training, so running that data through the system, there is cost for that. As an example, it can be something like $100 per hour. It's another example where the kind of AI costing is unpredictable because you don't necessarily know how many times you need to train the model, how long it takes. It doesn't look like a huge number, but if you go into a very complex model, as an example, the OpenAI's GPT-3 training cost $5 million, according to OpenAI, and they surely know what they are doing, so they didn't make any rookie mistakes there.
And I think this is, Mikko, one of the key things, at least based on what I have learned throughout this journey, is that I don't think people think about that too much. Everybody talks about LLMs and their use, but I think there needs to be some serious planning associated with it when you build anything internally, or if you are an ISV and want to build things, right?
That is true. So ChatGPT is like great platform in that it kind of inspires people, but it's a bit misleading because it's free.
Yeah.
So then people easily assume that I just take that and put it into my product or my IT and it's all free, and that doesn't quite work like that way.
Exactly.
Good. So that was the engineer stream. On the other end is then kind of the CFO stream. So we talk about prompt design and engineering. And prompt design really is the kind of input. What do you ask the model? And that is a very important part. It doesn't matter what you have under the hood. If the problem formulation is wrong, crap in, crap out. So it has a massive impact, and training people to ask the right question in the right way has huge impact. And it's in a kind of a CFO stream domain because it's not that expensive. So let's look at some, and then prompt engineering is another term, like it's more done by the specialists. So beyond the basic design of the prompt, the AI engineers and data scientists who understand the underlying model, they can better translate the requests to the language that the underlying AI model works. So while they understand natural language, they are not perfect at it. They're getting better and better. But like if you really know how to ask the right question, what parameters to set there, what limitations, what examples, you can get a better response, and that's the prompt engineering. And that's like a wide area. Design and engineering is a wide area. I selected some examples that have a cost impact here. And these, of course, are relevant if you have large volume. If your volume is very low, So you remember those 1K prices per like token prices. If they are fractions of cent or something like that, it doesn't really matter. But if you want to optimize, the first example is like just formulating your request or possibly reformulating that can save you 20%. So the difference is not huge, but it goes from 15 words to 12 words, which is like 20% off in the number of tokens. The middle example here is something about name entity recognition. And you can see the familiar example we used earlier. And then another example where Ramsri is replaced with John and SuperMeme is replaced with Google. So in some cases, the models recognize full words and they use just one token for that word instead of 3 or 4. And again, in this example, it's 36% off. And then the last one is like something that anybody can use in their own prompts, like prompt design, instead of asking to paraphrase something, the shorter version, longer version, a formal version, in 3 different requests, you can make one request and request all of these, and you can save 63%.
So in summary, you don't ever know exact cost when you feed something into the model.
You don't know, and that is very hard to predict how the users.
Exactly.
Good. So if you think about this, a couple of considerations there before entering into some like prompt engineering. Does the volume justify the cost and effort? You don't want to spend thousands to save tens of dollars. And then secondly, does the UX justify the cost and effort? People may not be perfect in asking the question, but you might be able to tweak the question so that it delivers a better response for them and improves the user experience. 2 totally different drivers, but like the means how to address them are the same. And of course, this all goes back to the user's experience. So who is the user? It's a very different thing if you have a few power users in your company and you need to educate them or help them, like engineer like tools for them, that they get better responses. It's a different case if you have other employees and you may need to train them. The further out you go to your partners, customers, so if it's even public facing application, the less means you have for educating them, and you may need to look into engineering for them. Good, so let's go back to this Copilot stack. So we covered the foundational models. We have discussed how to do the design, prompt engineering, and how to fine-tune the models. So the next one is then Metaprompt. And what that is. It's kind of closely related to the prompt engineering. If you have standing instructions that always apply to your product or solution, you can set them as meta prompts. And here is like on the right-hand side, you have an example of tone. So you can instruct the underlying LLM that your responses should be positive, polite, interesting, entertaining, and engaging. You must refuse to engage in argumentative discussion with the user. It could be about safety, the next example there. If the user requests jokes that can hurt a group of people, then you must respectfully decline to do so. And so on. There are other examples. So this is a way of like taking some of the burden off the prompt design or like engineering and putting like standing instructions. This is how in our organization, our product, the AI will behave. And this is closely related to the prompt engineering. What's common between these is that these kind of techniques, these changes are easier than engineering the whole model. So the fine tuning is much heavier lifting than doing like tweaking on the prompt level. So Petri, you had an example in mind about the Metaprompt. So why don't you go through that next?
Yeah, so this is really same thing as the prompting about doing it in multiple layers and including information from your own operational applications. So I think one of the key excitement that at least I have is the fact that these large language models are really truly now enabled to utilize the information that you have saved internally in your organization. So if you look at this picture here, you have a client application. And what is happening here is that the application itself will first, or the user itself wants to provide intent. And in this case, it's a product. So the person is searching for something, a product-related information using the large language model. And you can see the connection, the first layer, if you will, on top. Considering all the history, chat history, and customer information provided to that prompt. The next stage, the LLM returns the response set, and it goes and looks for the product in our own internal systems, so using cognitive search, and then amends that request, the prompt itself, into the final phase, where, and that's the final thing that the end user wants to get out of the solution itself. So you kind of see that you can do this prompting in multiple layers and also combining information from your own internal systems. And there's one key thing to remember. Microsoft and AWS and the other vendors, they're not using your information to build their own models or train their own models. So it's all kept under the security of that internal environment. And I have an example a little bit later on in this webinar, how Copilot for Office 365 works with internal information. So this is a good example of additional multi-layered prompting.
Good, thanks, Peter. So this is a good way to introduce then the next topic, which is grounding. Grounding is a process that connects the underlying model with the real world or domain-specific information. So you don't need to go and fine-tune the underlying model. You can tap into other data sources. And a good example of the grounding is RAG, Retrieval Augmented Generation, where you retrieve information from what they call a corpus. So it could be a database, it could be through API, it could be plugins. So you don't need to teach the underlying model. You tap into an external, like a data source. And then you augment the response and generate the response. And this one's really easier to explain through like examples. So we have two examples. I have a pizza example. It's a very simple one. And then Petri has like a Microsoft example that you can relate to. So let's look at the grounding in this case. So if you ask, give me a good pizza recipe, ChatGPT can give you that answer, but it's hard to differentiate through that. It's not going to be the kind of pizza recipe that people go for. It's the plain vanilla thing. But you could have like a library of cooking recipes, and you retrieve information from there, and then you understand, okay, how can I augment that pizza recipe? So I can give gluten-free options. It's summertime, so maybe I use different spices and herbs. Or it could be that the recipe is from Italy and your client is from US, and instead of deciliters, you want to use cups. And you can provide a more relevant response for them. So that's grounding in a very, very simple terms. And Petri, why don't you give a little bit more advanced example for us?
Yeah, let's look at this picture here. So what Microsoft is doing is to provide the connectivity to a large language model in the Office 365 environment. And if you look at this picture itself, so you have the different Office apps on top right corner, where the assumption is that you can, within those applications, you can prompt like you would in ChatGPT on OpenAI. You ask a question. But in this case, that prompt goes through the grounding process into what is called Microsoft Graph. Microsoft Graph knows everything about your emails, files, meetings, chats, calendars, contacts, and it also applies your own security settings. So it grounds the information. And what then happens, that initial prompt that we sent through the Copilot, it now goes in a modified form into the LLM itself. And then a response comes back. But what's interesting in this case, now it goes through all the security checks, making sure that all the settings and configurations that the organization has set for the language and all those compliance privacy rules, making sure that the large language model didn't return anything that it's not supposed to. So it's still being kept private. And then response goes back into the application itself. So it kind of makes this round through the grouting process into the graph. And this is how Microsoft is incorporating the LLMs into their products. And remember now, it's not LLMs. I mean, the Microsoft, it's not collecting anything from that instance, the Microsoft Graph instance. It's just utilizing that information to provide the response to the end user. Go ahead, Mikko.
Good, thanks. So that actually brings us to a couple of additional layers where we can do the customization. The first one here is the prompt and response filtering. So there are like automated tools where you can filter both ways, like Petri showed. So you can do prompt filtering, making sure that you don't send inappropriate or unwanted questions to the LLM. And here the examples are like what's currently in the Microsoft system are hate, sexual, self-harm, violence. You can toggle them on, off, and then you can set the aggressiveness of the filter. Is it low, medium, or high? And then in the same way, the answer coming back from the LLM, in case it incorporated anything that you don't want, it gets filtered again. So very handy tool to address like potentially a big challenge through an automated manner. And this is what we mean, like in AI, many of the problems have been solved. The heavy lifting is done. You just need to know which are the right models and tools for your needs and purposes. Then another one that came through like a Petri's example is the Copilots. So they are part of the stack here as well. And they are like an AI assistant enhanced feature. They exist across GitHub, Microsoft 365, and so on, or you can build your own. They can operate within an application like Word, PowerPoint, Teams, Excel. Typical examples like Petri provided in our first webinar, like automating tasks, generating stuff, summarizing, beautifying, and so on. Or they can operate cross applications. So they take content from one app and, for example, provide instructions to another app. There's a quite advanced Copilot in GitHub, not perfect, but getting there, that can code, test, comment the code, and so on. And the one thing to like note is that this terminology is a bit confusing because Copilot can mean this functionality, but the red stack that we've been looking at is also called Copilot stack in the Microsoft lingo. Then related to Copilots, there is something called plugins. And plugins are like third-party, they are means of calling third-party code that help with the Copilots. The plugins work across a different Copilot. So if there's a plugin built, it works with Word, GitHub, OpenAI, and so on. So reusable code in a sense. And on the right-hand side, if you have a good eyesight, you can see some familiar logos there. So there are tens of big-name developers in the ecosystem that have already developed the plugins. So you don't need to redo everything. You can plug into other players in the ecosystem. And these can really like work together. So you can fetch data, for example, from Thomson Reuters, do your magic, and as a result of that, update Jira. So you can build like workflows that are combining data and functionality from different places. So Petri, I'll let you give an example about this.
What Mikko showed in the previous slide really provided kind of the reasons why this is a very important topic for organizations. So if you look at the picture itself, it's multi-layered. So Microsoft is focusing on providing the user experiences using the Copilots, whether it's Power Platform, Copilot, and they also are trying to incorporate first-party app Copilots to everything that they do. So those are the internal applications that Microsoft is building. And then, of course, the one that I already mentioned, the M365 Copilot, and the previous webinar, we showed what it really means. And then one thing that is very exciting is the customer-built Copilots. And those could be any organization that wants to include functionality from a LLM in using their internal applications, and then using these thousands of different connections and security layers that Microsoft platform itself provides. And like Mikko said, it's a little bit confusing having Copilots for a specific product and then the entire platform being called Copilot. So the message here is that you don't have to build everything your own. You can utilize the platforms, the APIs that organizations such as Microsoft brings to the table.
Thanks. Good. So let's summarize then. This webinar has been about customizing your AI. We looked at the base model selection, which is maybe the most fundamental, biggest decision you make. It sets the token and hosting cost, and you can remember that the variance for same amount of data can be up to 300 times. You can fine-tune models. That was the engineer's dream kind of domain. Going to a fine-tuned model does add the cost. It can be 6x in the OpenAI world. It can be additional 2,000 a month in the Azure world. And these are just examples we use. So the other players have different models and pricing potentially. Fine-tuning can also improve the UX. So it's not only about the costing. It is like coming up with a better solution. It's one of the most important things is like knowing what you ask. So the prompt design that the users do, the engineering behind that is one consideration. Two typical drivers there. It can be driven by the user experience or by the cost. And you need to think about like who is the user and what is your capability of helping them. Metaprompts are the standing instructions that can be applied to every prompt in the background. Grounding is the way you access to the real world or domain-specific information. You have the prompt response and filtering, so both incoming and outgoing checks that nothing bad or unwanted travels between. And then we have the copilots and plugins, so that you can use the content within the app or between apps, and then connecting to the third parties who have already done the heavy lifting for you. Now then, finally, if we think about your kind of upcoming project, what are our hints there? So you need to understand your objectives. AI is not your objective. Your objective is to solve some pains, get some gains, and then that will give us clues like what are the appropriate systems and techniques for building that like optimized AI component there as part of the whole solution. You need to understand your resources. What do you have in-house? What kind of partners do you have access to? And then, of course, when you start looking at the cost, it's not just the cost, but it's also the opportunity cost. So it's not only how you can apply AI, but how fast you can do it. How fast can you get to those benefits? And remember, this space is moving fast. If you're not fast, somebody else probably will be. There's also something called incremental AI approach. So when you're starting your journey, it's better to build in steps. The world is changing fast. If you set like too ambitious goal from the get-go, it may be that you are stuck in it and the world has moved past when you're finally ready. This webinar is your quick start guide. You can refer back to the recording and see like what are the different elements, where do you start your customization, and then for the further resources, please reach out to us so we can help during your journey. So as a reminder, Petri covers the strategy through TELLUS, and ACX covers the design and development. We work in close collaboration so we can help you with all of your AI or solution building questions and get you to a good start and good finish with them. And as we mentioned, cost is such a big part of the AI model, so we have dedicated our third webinar, which is on August 16th, and we'll be looking at the underlying cost of making AI happen. We did touch some of those aspects here, but we will drill deeper. We'll give more examples, and we can look at the tool, how we can like calculate and estimate the tools. And then the other side of the coin is that if it's a solution that you're planning to sell externally, we'll explore the pricing and packaging principles for them. I think we have successfully consumed exactly 45 minutes. We'll take a look at your questions, and we promise to get back to all of those. At this point, we want to say thank you for joining us. We will provide the recording for you soon and hope to see you in the next webinar. In the meanwhile, if you have any questions, please don't be shy. Reach out to us, and we are more than happy to work with you. Thank you.
Thank you so much from my side as well.